All right, I just want to remind you all, if you have missed classes or if you're quarantined or anything like that, the recordings are on Schoology. You can click the link, go to the YouTube channel, and you can catch up on.
You post this on YouTube?
Post them on YouTube, yeah. So if I use fake names for y'all, that's why. Okay.
How many subscribers do you have?
What? How many subscribers? I don't know. Pretty famous on there. So here's our coordinate grid. Does anyone remember why we also called it the Cartesian plane? Cartesian?
Because you said it.
What?
Because you said it.
Because I said it. That's true. Has someone, yeah, his name was Descartes, right? That famous guy? Yeah, Descartes. Who's that? Descartes. He was that philosopher that said, "I think, therefore I am," which is terrible philosophy, in my opinion. But that's Western philosophy for you. He was one who was looking back and looking at his ceiling. That was what some guy said first period. He's the guy with the ceiling, right? It's like, yeah, he was the guy with the ceiling, sure. He was looking at it and he thought, oh, I could tell you exactly where something is if I cut it into a grid, right? And I could go left, right, up, down. Okay? Cartesian plane. So go ahead and flip this over. We're just going to do some points first. How many of y'all feel pretty confident about plotting points? Like you could, if you're given an ordered pair, you could plot points? 3 of you? Okay, well, 4 of you. We'll get that up to all of us by the end of class. How about maybe by the start of class? So someone who's confident, Susanna, I saw you. What are the coordinates for that ordered pair for A? 4, 4? Is that what you said? Yeah. 4, 4. Okay. And above that, go ahead and write x, y. Just like we were saying yesterday, x always comes before y. Anytime we have to give a point, it always involves 2 numbers, right? It's how far left and right and how far up and down. What's our rise? What's our, So 4, 4. Our x value is 4 on our number line, and our y value is 4 on our number line. That's where you end up at A. Okay? X comes before y in the alphabet. X-axis, you learn your x-axis, your number line before your y number line. I'm going to go ahead and label those x and y. Somebody in my last period said, well, ladies first. Ladies have 2 X chromosomes. Guys have a Y chromosome. So X comes before Y. Okay. B. Emma, you felt pretty confident. So what's B? What's the ordered pair for it? 1 and 2, right? Go over 1 and up 2. Okay, C. Who else? Blas? C? What do you think C is? Right here. How far are we going on X? 2. How far up are we going? 1. Yeah. Simple as that, right? All right, let's go over here to D. Gavin?
-4, +4.
Perfect. Guys, y'all are killing it. -4, +4. Right? X and then Y. All right. E. Who's got E? Somebody who hasn't answered. Daniel?
Yeah.
I think you've got it figured out. E. How far over on our x-axis?
E is -1 and +3.
Perfect. -1 and 3. All right. F. Ms. Hayden? -2, 1. Starting to feel a little more confident. Let's talk about G. Who's got G? London?
Oh,
Letter G. Where's that at?
there's not G in your name. Really?
So I want you to tell me, what are the exact directions? What's the exact location of this G here? On the x-axis, how far out are we? Negative. Okay, write that down, -4. And then on the y-axis now, so we're up and down, how far down are we? -1. Perfect. Garrett? Letter H. Give me the location.
-1 at y, x,
Uh-huh.
and then -3.
Perfect. And I, who has not answered? Skylar, aye.
-5, -3.
Okay, aye, let's see. -5 would take us out here.
No, it's
And then
-3.
-4.
-3.
-3 and then -5.
Is that right? Yeah, let me try one more time. Oh, -3 is first, and then you said -5, Skylar?
Yeah.
Yeah, perfect. X comes before Y. So always you're going here, right? If you're plotting a point, -3 and then -5. Good. Okay. Oh, we're not done. JKL. JK. So J. Somebody want to answer that one? Susanna? 1, -2. Emma, give me K. 3, -4. And Gavin, finish it off.
4, -5.
4, Okay. Y'all feeling a little more confident now? Okay. Good deal. So on this, now you can fold these in. I'll make a little foldable. That'd be fun. And notice quadrant 1, right? Quadrant 1. Every answer here, every coordinate here is going to be positive x value and positive y value. You see that? That's why I have that plus there. And look at your numbers. All of them were positive. Quadrant 2, which is to the left of it, we should have negative x values because you can see, right, when we fold it over, we just see our negative x values, right? So in quadrant 2, you should have everything negative x value and then positive y values. All right? And then quadrant 3, everything is negative, right? If we're just showing quadrant 3, we're only having negative x-axis and negative y-axis, right? So you can see why all of these points negative. All right, and then quadrant 4, we have positive on our x-axis and negative on our y-axis. Okay, so this is just really helpful, kind of visual, manipulative thing you can use for that. All right. Go ahead and set it aside. We'll do our gluing in a bit. And actually, we're going to take a pause from the notes, and I want you all to do this. It's just a simple, I know I gave you all one of these after the test. Okay, so slope measures the steepness. All right, we've used that word a couple times this week, steepness of a line. Right, the steepness of a line. One second. It's going to be our vertical change. It's going to be our vertical change, our up and down change over our horizontal change. Vertical over horizontal. All right. We'll also see that as rise over run. You know, you can represent that with up and down over, you know, your right and left. So kind of, these are just different ways to think about slope. Okay, the rate of change is how you heard it last year. We're calling it slope this year.
Wait, what do we call it? Last year.
Rate of change.
Oh, I never did that because it was so complicated.
Yeah, well,
we call it slope.
okay, you did good. Yeah, if you've already been calling it slope, I'm all about that. Okay, where did I put my? Let's see what I said first. All right. Now, one thing I wanted to just note before we start these is that all of our answers in slope, are not in decimal form. No decimals. No decimal. Sorry, I kind of got cramped. No decimals, okay? What that means is that when we're given a slope, we need to keep it it'll look like a fraction, okay? Don't worry about it. It's actually a lot nicer that it's a fraction because if it is rise over run, right, and I give you, I tell you a slope of like rise 3, go up 3 and go to the right 4, right? You want to keep it in those simple directions. You don't want to say, oh, it's a slope of 0.75. That would be correct, but that would also be confusing because this kind of gives you the steps. I go up 3 over 4, right? Rise over run. Okay, so no decimals. All of our slopes are going to be either fractions or whole numbers. Okay, no decimals when we do this. Starting with number 1, go ahead and just connect C to D. All right, just connect those dots. The reason we're doing so many connect the dots, other than it's just kind of fun, is whenever you have a line, right? If you want to draw any line, how many points do you need minimum? You need minimum 2 points, right? And any flat surface, if I want to, I have a point here, I have a point over here, right? I can connect a line, I can make a line from them. So in order to have a slope, you need to have at least 2 ordered pairs. You need to have at least 2 points. Okay, you can't have the slope. If I just drew a dot on the page and say, what's the slope of that dot? No answer, right? That doesn't work. You have to have at least 2 points for there to be a line and start talking about slope. Okay, so C to D. Go ahead and write rise over run. And again, don't get hung up on rise having to be positive, because you could have negative rise. I know that's a weird thing to think about, but I like to use the analogy of like an elevator, right? So we're going to say rise is kind of like the elevator. Run works, right? You can run backwards, you can run forwards, positive or negative, but you can rise up or you can rise down. So we're saying, how far are we going to rise to get from C to D? Well, obviously we're going down, right? So it's going to be a negative rise. The way you do this is put your pen or your pencil on C and then make these little bunny hops like I do. 1, 2, 3. All right, so we went down 3. I'm going to say negative 3 over 1, 2, 3. Okay, over a positive 3. All right, that can reduce to negative 1, right? A negative 3 divided by 3 is 1. Negative 3 divided by 3 is negative 1. Either way, that's your slope. All right? Negative 1. Okay. Slope is not distance, right? It doesn't matter. The slope from, let me zoom in for this, and I'll explain it again on a different line in a second, but the slope from here to here is negative 1. The slope from here to here is also negative 1. The slope from here to here, right? Barely any. The slope all along this line is the same. It's the same slope, right? Slope is not a distance, so don't try to count. Oh, the slope is 1, 2, 3, and a little bit, or something like that. Slope is a ratio of height, right, of up and down to horizontal distance. Okay, that's what slope means. It always, always, always is a ratio of these distances. Okay, a fraction. Number 2, B to C. Okay, that's going to be a rise of 1, 2, 3. That's it. Rise. I'm going to keep writing rise over run. I know y'all heard that a lot last year. You're going to hear it a lot this year. Rise of 3, a run of 1, 2, 3, 4, 5, 6. Okay, and really I want you to make sure you're doing this too, because I've had some students in the past, they miscount because they start counting their steps before they take a step. Okay, what I mean by that, like on this line, let's do A to E next. A to E over here. Okay, how far above E is A? Well, this one, no. We'll go back to that in just a second. No, it wouldn't. So A to E, it's 1, right? So don't count, whenever you're counting your little bunny hops, don't do 1, 2. That's not how you count it, right? Like if I was telling you to get from here to the wall, how many steps is it? I wouldn't say, well, it's 1, 2, 3, 4, 5. No, I would start, right? This is my starting point. I'm at 0. It's 1, 2, 3, 4, 5, 6, 7 steps, right? So when you start counting, you always have to draw your first bunny hop, and that's 1, 2, 3. Okay? So make sure today that you don't fall into that. I had a student last year who, I don't know how, but they got 2 weeks into this unit where they thought you were supposed to start counting, like instead of starting at 0, you're starting at 1. So they got a lot wrong with that. So, like for instance, now we're going to count how far over it is. I'm not saying 1, 2, 3. I say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? So that was A and E, and I said that was we said that was up 1 and a run of 12. So that's the slope there. Okay. BEF and BD are interesting situations. Let's start with B. No, yeah, let's start with BD. I'm going to start with BD. So go ahead and connect those. Anyone have any guess what the slope of that line is going to be? If you were just describing to someone, imagine you're on this graph, right? You're walking on it. Okay, we read from left to right, this direction, right? Just like these words are. Imagine you're walking across this, and you're walking up B to C. Is that going to be a positive slope or a negative slope? Positive, right? It's going up. Positive. Okay, now imagine you're walking from C to D. Positive or negative? Negative, walking down. Okay, B to D. How steep is that? It's just flat, right? So how sloped would you say it is? 0. Do y'all hear that? One more time. So I said if you're walking from B to D, right, you're just walking across the graph, and you're describing how steep it is, it's not steep at all, right? It's just flat. It's 0. Okay, so B to D, that's going to be 0. All right, and so, well, let me do this first. Now E to F. E to F, if you're walking, again, you're walking across, now you get to this, what would you say? What does it look like? What did you just come across? You came across a wall, right? Does a wall have slope or steepness? No. Okay, so this is actually going to be undefined. So over here, write undefined. If you have a straight vertical line like that, right? Unless you're Spider-Man, you're not walking up it, okay? That wall over there, if I was describing, oh, how steep is the wall? Nobody asks that question, right? If it's just a straight, if it's a flat, vertical wall like that, undefined slope. Okay? And the way mathematically we know this is we can still do rise over run. Okay? Rise over run. What is our rise from E to F? Well, we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we're going down 13. How far is our run?
13.
0. What is anything? So on your pull out your calculator if you don't have it. This is important. Tell me what negative 13 divided by 0 is. No, do it in your calculator. Negative 13 divided by 0. What do you get? Error, right? Doesn't do it. Calculator doesn't know how to do it. You remember that really exciting video I had y'all watch about dividing by 0? It's a couple weeks ago now. Y'all loved it. Obviously, because I'll remember it so well. You can't divide by 0. All right, it's not possible. Undefined. You can't divide something by 0. So if you see 0 in the denominator like this, it's undefined. So even rise over run, it still shows it's undefined. B to D, however, if we do rise over run, rise divided by run, we're running. Well, our rise is 0, right? I'm going to write it over here. Our rise is 0. Our run doesn't really matter, but 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 over 9. Now try that in your calculator. What is 0 divided by 9? 0. Okay, so you can divide 0 by something. You just can't divide something by 0. Okay, it'd be like if I handed you this paper and I said, cut this into 0 pieces.
Burn it.
Doesn't happen. Undefined.
Burn it.
Doesn't work. B and F. All right. Last one. Starting here, I'm going to do rise and run. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, I went too far, didn't I? I wasn't watching. My bad. I think it was at 6. 1, 2, 3, 4, 5, 6. Okay, so at 6, stop. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Anyone get anything different? So I got down 6, so minus 6, and then to the right 11, positive 11. Right? Because as we move on our number line, right and left, positive is to the right, negative is to the left. As we move on our y-axis, up is positive, down is negative. So negative 6 over 11. Any questions on that?
No.
All right. Yeah, we'll go and find the slope too. So first, let's just talk about positive, negative, undefined, or 0. Okay, you have one example of each on this graph right here. One of the ways I like to think about it is if I'm looking at it and I just want to know, is it positive or negative? I can always find it mathematically, right? I could say, well, this one was negative, that one was positive, so it's a negative slope, right? It's going down, though. I just like to think of it personally, just like we read from right to left, from left to right, rather, right? We read a graph, Wilton. We read a graph from left to right, right? No, left. I'm just messing with you. Okay, so look at A, right? So if you're just going to write, I don't know, I'm writing something random. Is this positive or negative? All right, and if you're reading this, is it going up or down as you're reading it?
Down.
Down, right? So it's negative. So hear that? Left to right, positive, it's negative. All right, over here, if I wrote the same thing, positive or negative, whatever, it's going up, right? Positive. Okay? Now, on this flat line, if I just wrote positive or negative, what would you tell me? Is it going up or down? Neither. Yeah, it's going straight. It's 0. Right? So 0 slope. So for line B, 0. 0 slope. For line A, we said that was negative slope, right? As we're reading, as we're looking across it, it's going down, negative. Line C, we said as we're reading, it's going up, positive. And then line D, if I just started writing positive, undefined, right? I can't even write on it, positive or negative. Okay, so that last one's undefined. That's just, I think that's one of the most helpful ways I ever heard of just when you look at a graph, knowing if it's positive or negative like that. All right, so D is undefined. Yes. Number 9 is positive. Right? And look at Wilton. Look at line C. Okay, it's moving from right to left, right? Because I know what confuses people is they say, oh, well, if I'm going this way, this line is going up, right? So they think, oh, maybe it's positive. No, we read from left to right. Like, we wouldn't read this sentence. We've already talked about this before. We don't go, enil kishi fruof epus, right? Determine the sign of. So just like we do that with words, we do that with our slope too. So this is moving down from left to right, negative. This is moving up from left to right, positive. This is not moving down or up, so it's 0. And this is just undefined. We can't even write on that one. Now when we find the slope of a line, we don't have points here like we did up here. Right? It's actually, a line is an infinite number of points. It's just, really, you could think of a line as, well, like over here. If I just drew a line, or I drew points, and then I drew more points, and then I drew more points, and more points, and I just kept just drawing points and points and points. Eventually, what do you have? you have a straight line, right? That's kind of what a line is. It's this infinite number of little points. The points that we're interested in, Hayden, are only the ordered pairs. Only the whole number ordered pairs. So that only happens right in the center of the, I call them hash marks, right? It makes like a plus across there. So those are the only options. And we're just interested, I'm just showing you like where they could be, but we're just interested on the ones that are on each line. Okay, but it can only be where it's centered. So on line A, let's draw some points. Let's find where it's centered. Here's a point where it crosses, right? So on your own paper, try to find another one. Where's another point on line A where it's centered right in the center of those hash marks? So I'm going along the line, not quite, not quite, not quite. Right here. There's another one. So that's at negative 1, 1, 2, 3. That's at negative 1, 3. You don't need to write that down, but these are at actual ordered pairs, right? This is at negative 1, 2, 3, 4, 5, 6. This is at negative 6, 5. Okay? Now we can count our slope. We can say, all right, it's a rise of down 1, 2, so negative 2, and a run of positive 1, 2, 3, 4, 5. Run of positive 5. So that's our slope for A. Line B, we said was 0. We already got it. And then line C, same thing. So find where it's crossing. It looks like it's crossing a lot, right? In fact, it looks like every hash mark is across. Okay, so we could pick this one and this one. We can pick this one and this one right next to each other. We could pick this one and this one. Will it have different slopes or the same slope?
Different. Wait. Oh, same.
Why the same? It's the same line. That's perfect answer, right? Like if I was to tell you, what is the slope of this floor here? 0, right? They'll walk on 0 most of the time. Downstairs, right below us, it's kind of slanted, right? So you're going up it, positive slope or whatever. But we'll do it like this. The slope from this table to Emma's desk, right, is 0. Okay, now what's the slope from this table to the desk in front of London? 0, right? The slope does not have to do with distance, right? It doesn't have to do with distance. Okay. All right, so we're just counting, going up 1, over 1, up 1, right, and staying on our line. So the slope is just 1 over 1, or 1. And to prove that, I could go up 1, 2, 3, 4, 5, 6, 7, 8, and I could go over 1, 2, 3, 4, 5, 6, 7, 8. I'm back on my line, so it's also a slope of 8 over 8, right? What is that simplified? What is 8 divided by? It's 1. Okay, so all of these slopes, right? I could count all the way up here, right, and say, oh, well, it's 97 over 97. 97 over 97 is also a slope of 1. Okay, so distance does not matter. All right, go ahead and fold it so you can see the.
Wait, what's A?
A is negative 2 over 5. Fold it so you can see the title. And we're not done yet. I want to write 2 more things on this fold here. Let me zoom out. Okay, so right here, just in the corner, just put rise over run so you can see it right when you open your journal. And that's up and down, not just up and down, and right and left. Have you ever seen those old-timey video games where it's like your character can just move like up and down and left and right on the game? You're like moving across the screen. Pac-Man would kind of work, yeah. Or like I'm thinking, what did I have? Not Kirby, but like a little Game Boy game. where you can like climb down ladders and then walk across the screen. You can basically only move this way, like up and down different levels, and then this way. Donkey Kong, sure. It's the same idea, right? You can rise, you can go up or down, you can run, you can go left or right, but you can't just cross the stage diagonally. Right on this graph here, you can't just you're not never just counting diagonally like that. It's always you can climb down the ladder and then go across the stage, right? Go up the ladder, go left here, right? You can move in these directions. You can't move diagonally. Okay. Last thing to draw. Some of y'all will have already seen this. I'm not usually enthusiastic about this, but it is helpful. Go ahead and draw this, and then we'll take our break. That's going to be
This looks like the climax of
positive, negative, 0, and undefined. All right, and the little story that goes with it is you got your little guy skiing, and he's going, and he says, puff, puff, positive. Right? You don't have to. Puff, puff. If this helps you remember it, though, then more power to you. Puff, puff, positive. Right? He gets here, he says, oh, that's his ski slope going down, nice, negative. 0, fun, because it's just flat. Skiing on a flat surface is no fun. And then he gets here, I don't know what they say. I think he dies or something because he goes off a cliff. But it's undefined. All right. Yeah, undefined. Wednesday, do you need to go to the bathroom? Boss? Yes? Yes? If you have a pass, you can go.
You can go to my passes. Not really passes for you.
When do we get the next pass?
Next week?
Next week?
End of next
We
week.
have 3 only delivered.
You have 6.
Oh, 6?
Yeah, you get to use them, each one of them twice.
I only used 2. I thought we could only use 3. Should have signed it right there.
Could have. But that way you know you can use them twice.
No way.